This video is the extension to our lesson on the real number system. Please fill out the note sheet as you watch this video. As we discussed in a previous lesson, the real numbers can be divided into irrational and rational numbers. What we'll discuss in this lesson is how numbers that are rational can also belong to other families of numbers, including integers, whole numbers, and natural numbers. Let's start with the natural numbers. Natural numbers are represented by the letter n, and these are numbers that are our counting numbers, like 1, 2, 3, 4, and so on, not including 0. Our whole numbers, represented by W, are those numbers that are our counting numbers and the number 0. So they include 0, 1, 2, 3, 4, and so on. Neither the whole numbers nor the natural numbers include any negative numbers. The integers, which we'll represent as z, notice we've already used I for irrational numbers, z for integers. You may be familiar with integers as being all the whole numbers and their opposites, so all negative numbers and positive numbers that are whole numbers. So -3, -2, -1, 0, 1, 2, 3, etc. Let me take a space out of there. Okay. So here we have the three new sets of numbers that we're going to talk about: integers, whole numbers, and natural numbers. You'll notice that the whole numbers contain all of your natural numbers and the number 0. So the natural numbers are a subset of the whole numbers. Similarly, the integers contain all of the whole numbers and the natural numbers. The integers contain both of these sets of numbers. So the whole numbers are a subset of integers. Natural numbers are a subset of both whole numbers and integers. So let's move on to the next part of the exercise, which is to identify for each of these numbers all of the sets of numbers to which the number belongs. So let's start with 30. 30 clearly is a real number, so we can put an R for real. It is also a rational number because it is a whole number. We could represent it as 30 over 1, so we'll put a Q. And remember, in the rationals we have integers, whole numbers, and natural numbers. 30 is an integer. It is also a whole number, and it is a natural number. It's positive, so it is a whole number and a natural number. Next, let's look at number 2. The number -11. All these numbers on our list are real numbers, so I'm going to start with R for real. -11 is also a rational number, so we'll start by deciding whether it's rational or irrational. This one is rational. It is an integer. Is it a whole number and a natural number? Well, it's negative, so it's not a whole number or a natural number, so we'll stop there. 3, 5 and 4/7. 5 and 4/7, we'll start by saying that it is a real number. Is it a rational number or an irrational number? Well, we can see that it has a fraction right in it. We can turn this into an improper fraction, which means this is rational. So we'll put a Q for rational. Is it an integer, a whole number, or a natural number? Well, it is not any of those because it does have the portion that includes that fraction. So we'll just stop with real and rational. Let's look at square root of 21. Let's start with real. We know it's real. They're all real. The square root of 21, is it rational or irrational? Well, let's look in the square root. The square root of 21. 21 is not a perfect square, so we will call this irrational. And if it's irrational, it can't be any of those other sets because those are subsets of the rational numbers. Let's take a look at the next one. 0 is a real number. Okay, is it rational or irrational? Well, we've discussed this one before. It could be written as 0 over 1, which makes it a rational number. Is it an integer, a whole number, a natural number? It is an integer, so I'll give it a Z because it is one of those whole numbers. It is a whole number. It is 0, 1, 2, 3. That set contains the number 0, so I'm going to call that a whole number. Is it a natural number? Well, if you look back at your notes, a natural number, those natural numbers start with 1 and continue upwards. So 0 is not a member of the natural numbers. So we'll stop there with real, rational, integer, and whole number. So let's take a look at the next one. Negative root 9 is equal to negative 3. We've discussed this one before. Let's consider the number negative 3. Negative 3, we'll start with real. Is it rational or irrational? Negative 3, looks like it could be written as a ratio, negative 3 over 1, so we'll call it rational. Is it an integer, whole number, natural number? We see that it is an integer. It's negative though, so it can't be a whole number or a natural number. Pressing on to 6 over 3 is equal to 2. Let's start there. 2 is a real number. Is it rational or irrational? Well, we just saw it written as a ratio of 6 over 3, so we'll give that rational. And rational numbers could be integers, whole numbers, natural numbers. Let's see, 2 is an integer. It is also a whole number because it is positive and a positive integer. And it is a natural number. It's positive. It's in that set of counting numbers. So it looks like it's a member of all of those subsets. Pi, we know pi is a real number. It is irrational. It's our most famous irrational number so far. And we'll stop there because irrational numbers cannot belong to any of those other subsets. Next, 5.3 repeating. We'll start with real there. Remember, 5.3 repeating. 0.3 repeating is a repeating decimal. Therefore, this would be a rational number. We could rewrite it as 5 1/3, which could then also be written as 16/3. So that is rational. Now that we know it's rational, we have to see, is it an integer, a whole number, or a natural number? In this case, it is not an integer, a whole number, or a natural number because it does have that decimal part. So there are our categorizations for those numbers. Next, I'd like to show you the Venn diagram showing the relationship of irrational to rational and all of the subsets of the rational numbers. This diagram, I think, really clearly illustrates that rational numbers contain the subset of integers, integers contain the subset of whole numbers, and whole numbers contain the subset of natural numbers. But as you can see, there is some space in between them. So there are some rational numbers that are not integers. There are integers that are not whole numbers, and so on. There is a whole number that is not a natural number. So let's go through our list and place some of these. Okay, A is 7. That would be a rational number, so we would put it on this side. It is an integer. It's positive, it's a whole number. It's a natural number. We can put it all the way inside this part of the circle. Okay, next, B, negative 32 twelfths. That is the same thing if we simplify it as negative 3. I'm sorry, negative 36 twelfths. That is negative 3. Negative 3, let's see where we could put that. That is a rational number. We just saw it as a ratio. It is an integer. Is it a whole number or a natural number? No, because it's negative. So we're going to put it in this ring. We're going to put it in the integers, but not the whole numbers or the natural numbers. Letter C, negative root 36. Negative root 36 is equal to negative 6. 36 is a perfect square, so this is -6. This is a rational number. -6, where would we put -6? It's rational. It is an integer because it's negative, but it's not a whole number or a natural number, again, because it's negative. So we'll put a C here in the integers, but not in the wholes or naturals. D is pi. We know pi is irrational, so let's just put that right there. E, 6.48, that is a rational number because it is a terminating decimal. It ends, so it would go in the rationals. Is it an integer? It's not an integer. It's not a whole number of any sort. So we're going to put that in the rational ring. Okay. F, -2, is a rational number. Any of our whole numbers, integers, and so forth is a rational number. And it's negative, so we are going to put that in the integers ring. It cannot be a whole number or a natural number. G, -√10. -√10, irrational, because 10 is not a perfect square. And 0, as we discussed on the previous page, is rational. It is an integer, and it is a whole number. But remember, the natural numbers do not include 0. So 0 would be a whole number that is not a natural number. So we put that in this ring for whole. 2 1/6 is a rational number. It's not an integer because it does have that fractional part, so we're going to put that here under irrational. I'm sorry, under rational, but not integers. J is -0.7 repeating. That is a repeating decimal, therefore it is rational. But it's not an integer, again, because it has a decimal portion. So we'll put a J there. And finally, the last one, we have the square root of 4/81. This is the same thing as 2/9. 2/9. Is that rational or irrational? Well, it's clearly rational because it is written as a ratio. However, it is not an integer, whole number, or a natural number. So we will put K in the rational ring. At this point, we are coming to the end of this lesson. This is the extension lesson. So once you've completed your note sheet, please return it to Mrs. Morris, and I will give you an exercise to try to practice doing this on your own, categorizing integers, whole numbers, and natural numbers. Thanks for watching.